Welcome to the first lesson in Session 8 on the fundamental theorem of algebra. The fundamental theorem of algebra provides some interesting information about polynomials and their solutions. Now for this lesson, we're going to refer to solutions as roots and zeros, but they all mean the same thing. It's where the polynomial is equal to 0. We call it a solution, a root, or even a zero. So the fundamental theorem of algebra states that a polynomial of degree n has exactly n zeros. So the degree of a polynomial is equivalent to the number of zeros that that polynomial contains. Now the degree of a polynomial in a single variable polynomial is the largest exponent of that variable. And a zero, or a solution, or possibly the term root, is where the polynomial is equal to 0. So I'll give you a few examples, and we're going to identify the number of zeros for each polynomial. The first example, we have 4x to the third plus 2x squared minus 7. This is a third degree polynomial because the largest variable exponent is 3. So a third degree polynomial will have exactly 3 zeros. X squared plus 2x minus 10. Here we have a quadratic trinomial. So this quadratic will have exactly 2 zeros. The next example, x to the fourth plus 7x to the third minus 10x. This is a fourth degree polynomial. We'll have exactly 4 zeros. And lastly, we have negative 3x plus 8. So this is a first degree polynomial, and it's going to have exactly 1 zero. In addition to the number of roots we can identify, the fundamental theorem of algebra will also give us information about the nature of roots. When we're talking about the nature of roots, what we mean is real roots versus complex roots. First, we're going to start with real solutions. Real solutions can be rational or irrational. Irrational solutions are generated by taking the square root of a non-perfect square. Thus, for that reason, they will always come in pairs because you always have a positive and a negative version. Complex solutions, very similarly, are generated by taking the square root as well, but they're generated by taking the square root of a negative number, but still they will always come in pairs. So complex solutions always come in pairs, and irrational real solutions always come in pairs. So a real solution can be rational or irrational, or the third type of solution is complex. This helps because we can identify the nature of solutions by analyzing the degree of the polynomial. So we know a first degree polynomial has exactly one root, and we know that there's only one option. It's going to have to be a real root. A second degree polynomial has exactly 2 roots, and it can be 2 real or it can be 2 complex. Third degree polynomial's got some different combinations. We know it's got exactly 3 roots. They can be 3 real roots, or it could be 1 real root and 2 complex roots. A fourth degree polynomial has exactly 4 roots. So that can be 4 real roots, it can be 2 real roots and 2 complex roots, or it can be 4 complex roots, so on and so forth. But the idea that irrational numbers and complex solutions always come in pairs help give us information about the nature of the roots. Now a number will be called a root if it satisfies the equation. So a root can also be referred to as a zero or a solution. As previously stated, those 3 terms are all interchangeable: root, zero, and solution. Now when looking at the graph of a function, it's easy to see that real number roots can also be identified by x-intercepts. So wherever you have a real number solution, graphically you can identify x-intercepts. Complex roots do not cross the x-axis. So in the following function, f of x equals 4x to the third plus 2x minus 6, we're going to analyze the equation to identify the nature of the roots and how many there are. So we know we have a third degree function, so the fundamental theorem of algebra tells us there are exactly 3 zeros to the function. Furthermore, we know that there are 3 real solutions, or there's 1 real solution and 2 complex solutions. So we're going to take a look at the graph. If the graph crosses the x-axis in 3 distinct places, we know that there's 3 real solutions. However, if it only crosses one place, then we know there's 1 real solution and 2 complex solutions. So let's take a look at the graph. Analyzing the graph tells us that there is one real solution at x equals 1. We can conclude that the other two solutions are complex. That wraps up this lesson. Good luck on the quiz, and please email us if you have any questions.